The most abundant mineral in the Earth's crust explained. When you look around, from the glass in your windows to the grains of sand on the beach, even the mountains in the distance, you're seeing the most abundant mineral in Earth's crust. It makes up more than 12% of the planet's outer layer, yet most people don't even know its name. It's everywhere, in rocks, in rivers, in deserts, in technology, even inside your watch and smartphone. Today, we uncover the story of quartz, the quiet powerhouse of our planet, a mineral so common that it shapes both nature and human civilization. Quartz is a mineral made of two of Earth's most abundant elements, silicon and oxygen. Its chemical formula, SiO2, may look simple, but from this humble pairing comes one of the most versatile materials on Earth. Quartz belongs to a group of minerals known as silicates, which dominate the crust. Its structure consists of silicon atoms bonded to oxygen in a repeating, three-dimensional framework. This framework gives quartz its durability and stability. Unlike many other minerals, quartz doesn't dissolve easily, doesn't melt at ordinary surface temperatures, and doesn't crumble under weathering. And quartz isn't limited to one look. It appears in countless varieties. Clear quartz, often called rock crystal. Amethyst, tinted purple by traces of iron. Rose quartz with its soft pink glow. Citrine, golden from natural radiation effects. Smoky quartz, darkened by radiation within Earth's crust. From dazzling crystals to dull grains of sand, quartz is everywhere. And that's because its ingredients, silicon and oxygen, make up the bulk of the crust itself. Whenever they combine in cooling magma or sedimentary processes, quartz forms naturally. It is the mineral Earth can't help but make. You've interacted with quartz today without even realizing it. The sand beneath your feet on most beaches, that's quartz grains, eroded from granite and sandstone over millions of years. The glass in your window or smartphone screen, made from melted quartz sand, reshaped into transparent sheets. Even the countertops in kitchens, so glossy and sleek, often come from engineered quartz, where crushed quartz grains are bound with resins to create durable surfaces. Beyond homes, quartz is vital in industries. It's ground into fine powders for paints, ceramics, and abrasives. It's melted into silica glass for laboratory equipment and optics. It's used in water filtration systems because of its hardness and stability. In short, quartz is not just a mineral in the ground. It's the foundation of daily life. Every time you look out a window, walk across sand, or use electronics, you're depending on quartz. Quartz isn't only a part of human technology. It's a defining ingredient in Earth's landscapes. Take granite, for example. This common continental rock is a mixture of quartz, feldspar, and mica. Granite makes up the backbone of mountain ranges across the world. Without quartz, granite wouldn't exist. In sandstone, quartz grains accumulate in layers over time, cemented together into rock that can last for millions of years. Many of the world's cliffs, canyons, and natural arches are built largely from quartz-rich sandstone. Quartz is also what survives when other minerals crumble. Because it resists weathering, quartz grains are carried by rivers and deposited in beaches and dunes. The vast deserts of the Sahara and Arabian Peninsula are filled with quartz sand shaped by wind. Even riverbeds and glacial valleys are dotted with quartz pebbles, proof of its incredible durability. Over and over, quartz cycles through Earth's surface processes, outlasting weaker minerals and becoming the dominant survivor. Quartz hasn't only shaped landscapes, it has shaped human imagination. The ancient Greeks believed quartz was eternal ice sent from the heavens, frozen so deeply it could never melt. The word crystal itself comes from the Greek kristallos, meaning ice. In ancient Egypt, quartz was carved into amulets believed to protect the wearer. The Chinese crafted jade-like carvings from milky quartz. In pre-Columbian South America, shamans used quartz crystals in rituals, believing they connected the physical and spiritual worlds. Throughout the Middle Ages in Europe, quartz was thought to have healing properties. People carried crystals to ward off illness and misfortune. Even today, quartz remains central in modern metaphysical practices, where it is said to channel energy, promote clarity, and amplify intentions. Whether or not these beliefs hold scientific merit, one thing is certain: quartz has always fascinated humanity, not just for its beauty, but for the mystery it seems to hold within. But quartz's greatest magic may lie in a property called piezoelectricity. When quartz crystals are squeezed, twisted, or struck, they generate a tiny electric charge. Conversely, when electricity is applied, the crystal vibrates at a precise frequency. This remarkable feature makes quartz an energy converter and a timekeeper. That's why quartz became central to technology. In watches and clocks, quartz oscillators vibrate consistently, keeping time more accurately than mechanical gears. In radios and electronics, quartz stabilizes signals. In computing and telecommunications, quartz crystals serve as precise frequency controllers, enabling global communication networks. But the story doesn't stop there. Quartz also plays a role in fiber optics, where purified quartz glass transmits light signals across oceans. Semiconductors, as silicon wafers, derived from quartz sand, are the base of microchips that power computers and smartphones. Solar panels, where quartz-derived silicon converts sunlight into energy. In short, quartz isn't just abundant, it's indispensable. Without it, our digital world would collapse. Quartz isn't limited to a few regions, it is found almost everywhere. Major quartz deposits exist in Brazil, Madagascar, the Alps, and Arkansas in the United States. Giant crystals weighing hundreds of kilograms have been pulled from mines, but quartz doesn't stop at Earth's surface. In meteorites, tiny quartz grains survive the violent journey from space. On Mars, rovers have identified silica-rich rocks resembling quartz, offering clues about the planet's volcanic and watery past. In many ways, quartz is not just Earth's most abundant mineral, it may also be one of the most universal markers of rocky planets. Its stability and durability make it a natural survivor across the cosmos. As abundant as natural quartz is, humans have gone further. We've learned to grow quartz crystals in laboratories. Synthetic quartz is used in electronics, lasers, and scientific instruments, ensuring precision and purity beyond what nature provides. Looking ahead, quartz will continue to play a role in advancing technology. From quantum computing to next-generation solar cells, from medical instruments to space exploration equipment, quartz will remain at the heart of innovation. In an age where rare materials often limit progress, quartz stands out as both abundant and essential. It is proof that the most valuable resources aren't always the rarest. Sometimes abundance itself is the greatest gift. So the next time you walk barefoot across a sandy beach, admire a mountain of granite, or glance at the glowing screen of your smartphone. Remember, you're touching quartz. It may not be rare and it may not dazzle like diamonds, but quartz is Earth's quiet powerhouse. It shapes our landscapes, builds our cities, powers our technology, and even connects us to the stars. Which form of quartz fascinates you the most? The clear elegance of rock crystal, the purple majesty of amethyst, or the soft beauty of rose quartz? Share your thoughts in the comments. And if you love exploring the extremes of our reality, from the rare to the abundant, push the like button and subscribe for more journeys into the extremes of reality.